This next one, we're solving a cubic inequality. Really, it could be any power inequality. The reason I put it on here is because it's one that I cannot solve by factoring. If I were to begin by factoring it, I can take the x out and leave x squared plus 5x plus 1. But this part right here does not factor. Okay, so that becomes issue, is we have to solve that part that doesn't factor. We do have this out here, which would give me a 0 of x equals 0. And so I've got that, but the question is, what are the other two solution points that would come from this that doesn't factor? So what I'm going to do is I'm going to use the graphing calculator to help find those spots. And so I'm just going to type in the entire inequality here. I've got x raised to the third plus 5x squared plus x. And let's just kind of see what this looks like. Now what I want to know is, where does it cross through the x-axis? It crosses through out over here. So let's find that point first. So I'm going to calculate the 0. I need to move my cursor to the left side. Okay, there it is right there. You can see it flashing. I need to keep going to the left to get it on the other side of that. So somewhere to the left, hit enter. I'm going to bring it back to the right side of that. I'm going to hit enter. And I got a 0 at negative 4.79. So let me write that down. Okay. So we've got that 0 at negative 4.79. We already know there's one at 0, and it does appear that the graph crosses through at 0. But there might be another one real close there. So all I'm going to do is zoom box right close to the origin just to see what's happening there. You might find out that it crosses the x-axis more than once. And sure enough, it does. So let's find that other one. Calculate the 0. That's the one right there at the 0 that we found with the common factor. So I'm not interested in that one. I want this one over here. So I'm going to go to the left side of that one. I'm going to go to the right side of that one. Do not go too far right that you go all the way to the right of that one, because the calculator cannot find two zeros at the same time. So just left and right of that single 0, it's negative 0.21. So let's write that down. Okay, so I've got my 3 zeros. Now let's show how I'm going to get this solution utilizing the graph of this. Okay, and my graph's going to be real rough. It's not going to be that accurate. But I know it crosses over here at the negative 4.79. It crosses here at the negative 0.21. And it crosses right here. If you recall the original picture, just to kind of get an idea of what it originally looked like, I'm going to just recreate that. Not exact by any means, but it went up first, then it went down, and then it went back up right there. Something like that. Alright, what we want to know is, where is the graph of this? Okay, the graph of this curve that I see here. Where is that graph greater than, which means above, the x-axis? Well, it's above the x-axis right here. It's above the x-axis out here. I need to write those two solutions. So it is above the x-axis between negative 4.79 and negative 0.21. Also from 0 to infinity. So when factoring failed right here, I could still find these solutions. We just had to use the graphing calculator to find them. And then we would just kind of revert back to, let's look at the picture of the graph, see where is it above, below the x-axis. This particular problem we wanted above, and we got our solution sets from that. Finally, I want to touch upon, just real briefly, projectile motion type problem. We have a projectile motion formula or position formula. Looks like this. S of t equals negative 16t squared plus v naught t plus s naught, where the v naught is the initial velocity, the s naught is the initial height or position. Where did it start? T is the independent variable, s is the dependent variable. So, graphed, you'd be graphing t and s of t like that. So those are your variables. Your s and t are going to stay. You need an initial velocity, initial position, and then this formula will do that. One note, the negative 16 is if the units are feet. If the units are in meters, then the negative 16 is negative 4.9. Okay. Our text typically uses feet, but on occasion you see meters per second, that sort of thing, and then you just a little simple change. Okay, this problem says a projectile is launched straight up from ground level with an initial velocity of 288 feet per second. Let's model it first. S of t is negative 16t squared plus v naught t plus s naught. This becomes s of t equals negative 16t squared plus the initial velocity 288 t. From ground level, well, what is the height at ground level? The height is 0 feet at ground level, so the s naught in this particular model is 0. Okay, so this is the model that we're going to be working with, or this is going to be the function that models where the projectile is at a specific unit of time. So if I want to know where is the projectile, how high above the ground is the projectile at 2 seconds, well, then I put 2 in for the t's and I work it out. That's what this model tells us. Okay, so what I want to know is when, question A, when will the projectile's height above ground be 1,152 feet? So solving for when, which means I'm solving for t, I'm going to set the height at 1,152 feet. And we're solving this equation here. Well, so let's see. I'm going to move everything over to the left-hand side. So the negative 16t squared becomes positive 16t squared. That 288 becomes negative 288t plus 1,152 equals 0. Let's see if I can reduce the numbers. I can divide everything by 16, so this becomes t squared minus 18t plus 72 equals 0. And now can we factor this? Is it possible to factor this? we find that we can factor this. It's going to be t minus 12 and t minus 6. 12 and 6 multiply to 72 and add to negative 18. So at t equals 12 seconds and t equals 6 seconds. You might ask, why is there two answers? Because the projectile is shot straight up. It's going straight up, and then it's going to come back down. So it's going to hit this height of 1,152 feet on the way up after 6 seconds, and on the way back down after 12 seconds. Okay. Part B, when will the projectile's height above ground be at least 1,152 seconds? So at least 1,152 feet, but at least 1,152 feet means it can be that or above that. Okay, and so we think of this projectile starting at ground level and shooting straight up. At 6 seconds it's hit that height, but it keeps going up. And then it starts to come back down, and at 12 seconds it hits that height again. So it's going to be at least that high above ground between 6 and 12 seconds. So you could either write it like this, maybe between 6 and 12 seconds, or I might just write it like this. Okay. And then part C. When will the projectile return to the ground? Okay, well, it's going to return to the ground when it has a height of 0. So I'm going to set the s equal to 0. Okay, I can divide everything by negative 16. So 0 equals t squared minus 18t. We can factor out a t. So it's at the ground when t equals 0. That makes sense because it starts at the ground and time starts at 0. And it also hits the ground after 18 seconds.